Welcome to Chapter 8. This is a chapter that is called Roots and Radical Expressions. And 8.1 is the definitions and common roots. And we're just going to kind of introduce roots and radicals and radicands and indexes and all that kind of stuff. So be ready to put some notes down as far as definitions. But at this point in your mathematical career in this class is, first of all, understanding what these symbols mean. Okay, so just remember, this is 3 times 3. This is 2 times 2 times 2. All that radical sign does is tells you how many times to multiply the base. And some of you have a calculator that will do that, hopefully, because when you get numbers like this big old Herkin one, makes it a little bit difficult. But this one, is going to be 9. 2 times 2 is 4, times 2 is 8. 2 times 2 is 4, times 2 is 8, times 2 is 16. I have no idea what that is. All right, so you know this, how to do that. Radicals, or square roots, goes backwards. It goes in the opposite direction. Okay? This squares a number, but what if you're given the number and you want to go back to the 3? Okay? What you do is you have a symbol here, and this makes the reader aware of what you're asking for, or the book will put it that way so you know what it's asking for. And what this says is what number times itself gives me 9. There is a number that goes in this little part here, and let me make the sign a little bit bigger. It's actually a 2. And since we're going to be dealing with square roots, and the index is 2, we just assume you know that, so we don't put a number in there. We just assume that you know there's a 2. If there is a number other than a 2, we'll tell you. So this is called the index. And what that is it says, all right, so what number times itself 3 times gives you 27? In this case, it's 3 times 3 times 3. So what number times itself 3 times? 3 times 3 is 9, times 3 is 27. If I had a 4 in there, I'd say what number times itself 4 times gives me 81. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Okay, so that just tells you what number times itself that many times is going to give you 81. So see, it's very similar to these because we have a number here that says how many times are we going to multiply 2? 4 times. This says how many times did we multiply 4 to get 81? Okay, so we multiplied 3 4 times in order to get 81. So that's what the radical sign means, and that's what the index does. So it's just going in the other direction. Some people absolutely hate radicals. Some people like them. I'm one of the strange ones that actually likes them. So, square root of 25. This is the radicand, is what that's called. The number that goes in here is called, I said before, the index. And this is called the radical sign. Okay? So the whole thing together, the whole stinking kit and caboodle, is called a radical. Whenever you put a sign over it like that, you have a radical. Now, if you go to top of page 524, it says, If x represents any positive real number, then the expression square root of x is the positive square root of x, or the principal square root of x. It is the positive number we square to get x. The expression negative square root of x is the negative square root of x. It is the negative number we square to get x. Okay, so basically they're just saying a whole bunch of stuff that is all true and needs to be said, but is said in a way that's pretty confusing. Okay, so Pretty much what we've got here is when we're asking for the square root of 25. Okay? What number multiplied by itself gives me 25? Well, we get two different options here. Negative 5 times negative 5 is positive 25, and 5 times 5 is positive 25. But what the book is saying with that definition is we have what they call a principal square root. Square root, that's an S. Principal square root is the positive answer. So when they say, what is the square root of 25? Even though it's positive 5 and negative 5, the principal square root is positive 5, and that's usually what they're going to ask you to give them for an answer. What is the positive number multiplied by itself that gives you 25? Now, sometimes we'll kind of go back and forth, but for the most part, they're going to ask you for the principal root, the positive number. All right. So every positive number has two square roots. Like we had mentioned before, square root of 25 is a positive 5, and remember how I wrote it in the last section? That means, so you don't have to write the 5 twice, you just write plus or minus 5. So every positive number has two square roots. And one of the things that I want you to realize, it says every positive number. There is not a square root of negative 25. Because if we multiply negative 5 times negative 5, we get positive 25. The only way we can get a negative 25 is if we multiply positive times a negative, we get negative 25. But the question is, are those the same number? Remember, we're finding a number that when you multiply it by itself, you get this number in here. So we have a number that we're multiplying, but we're not multiplying by itself, because one number is a negative 5, one number is a positive 5. Those are numbers that have the same 5, but they are two different places on the number line, which means they are two different numbers. One is negative 5, one is positive 5. They are not the same number unless they land on the same place on the number line. So this is not, I mean, that's a true statement, but the square root of negative 25 does not exist. There is not a number you can multiply by itself that gives you a negative. All right, until you get to college algebra or intermediate algebra. I guess it's intermediate algebra where you deal with, okay, I know you're going to shoot me for saying this, but you start dealing with what are called imaginary numbers. So it's like, oh my gosh, really? I'm having a hard enough time with real numbers, and now you're going to tell me there's numbers that are in my imagination that we're going to work with? Yes, there are. And that will be in intermediate algebra. Those are introduced. But since you're not there yet, phew, we don't have to worry about it. All right, so anyway, square root of 36. What number times itself gives me 36? Okay, not too hard. What if I have negative square root of 36? Well, you find out what square root of 36 is, and you tag a negative on it. Square root of 36 is 6. Tag that negative on it. What if we have 1 over 36? What that means is you split that radical up. What is the square root of 1? What number times itself is 1? 1. What number times itself is 36? And you're done. Okay? So, let's go to some irrational numbers and deal with some of those. Now, you don't have to understand exactly what irrational numbers are in order to solve for irrational numbers. But let's go ahead and look at some. For example, the square root of 5. Is there a number multiplied by itself that will give me 5? Yes, there is. But it's an irrational number. It's not a number like 1, 2, 3, 4, 5, 6. It's a really, really long decimal. In fact, let me get my calculator out and do that. And we get a number 2.236067978, and it goes on forever and ever and ever. And that's what an irrational number does. It goes on forever and ever and ever. So usually, when you're doing work and somebody says, what's the square root of 5? It depends on what they're asking, but sometimes you just say, it's the square root of 5. The number goes on forever. Or you might just go, oh, it's somewhere around 2.3-ish, 2 1/4, something like that. I know when I'm building and I come up with a radical when I'm, doing psychomath, when I'm building a building, I'll just look at this and say, oh, about 2 1/4 inches or 2 1/4 feet. So kind of guess there or estimate there. But anyway, let's go on with irrational numbers. So let's look at some different cases here. So the square root of 0. Square root of 0. You're not going to run into this very often, but what number times itself gives a 0? Well, any number times 0 is 0, but the question is what number times itself is 0? Well, 0 times 0 is 0. So the square root of 0 is 0. All right, square roots of negative numbers. Now, I brought this up a little bit ago. Negative numbers have square roots, but like I said before, they're imaginary, and you can't put them on the number line. So that's why they're imaginaries. You can't represent them graphically. So the square root of negative 4, what is the square root of negative 4? There isn't one. Okay? At least for what we're doing right now. So there are lots of other roots that we have. I had mentioned something like the cubed root of 8. What number times itself? 3 times, because the index tells you how many times you're going to write the number, is going to give me 8. Let's say I had something like the cubed root of negative 27. And you're going to say, oh, there's no answer. No. I said square root of negative 27. There is not a number times itself that's going to give me a negative 27. But there is a number times itself 3 times that will give me a negative 27. Watch. Negative 3 times negative 3 is positive 9. 9 times negative 3, a positive times a negative, is negative 27. So the cubed root of negative 27 is negative 3. Which brings me to a truth here. If the index is an odd number, you can take that root of a negative, okay, which I did and got negative 3. Negative 3 times negative 3 times negative 3, 3 times. If this number here is an even number, like 2 or 4 or 6 or 8, there is not a root of a negative. Okay, so that just kind of gives you a clue of how you would do that. Now, clear at the bottom of page 525, there is a list of different roots, square roots, cubed roots, and fourth roots. And kind of there just to help you out. Now, when you're doing this math, and if you end up with an answer like the square root of 89, that's the answer I want you to put down. I don't want you to put it in your calculator and get 9.0321. I mean, I don't want that kind of an answer. I want it left in radical form, because radical form is more exact than this. This is just an estimate, because like I say, this number here goes on forever. So you can only give me part of it, right? Because your numbers can't go on forever. This is the exact representation, the square root of 89. This basically says forever. Okay? So rather than writing 9.0321 into infinity, you're just writing the square root of 89, which means forever. All right, so that's it for 8.1a, and we'll continue with 8.1b.